Hi, and welcome to the TD Meetup. My name is Alexander Richter. I'm a technical director for visual effects, animation, and games, and I worked at companies like WeatherFX and Framestore on Avatar: The Way of Water and Monsters at Work.
Hey everyone, welcome to the TD Meetup. It is an event that we do each month to talk about additional topics that you need besides Python, besides diving into the industry. We had talked about AI introduction. We talked last month about presentation skills for TD tech nerds, basically. And this month, we want to talk about visual effects pipelines. And the reason is very simple. Every one of us uses them. Even if we don't write them, we definitely are part of a pipeline, visual effects, animation, and games, of course. And that means that we are constantly surrounded by them. And especially if we strive to work in a more technical field, even if we don't become pipeline technical director, it's good to understand how they generally work so we can work with them in collaboration with them, we can add to them, or we even contribute and write them ourselves. And the idea here and today is to demystify visual effects pipelines, what they actually are. And then I will start with an introduction into visual effects pipelines, how I broke it apart. And for everyone who's joining my Python Advanced Masterclass, this is kind of something that we kind of touch upon with the open source pipeline Plex. But it's also going deeper into the details of how a visual effects pipeline actually builds. Basically, with the knowledge that I will introduce today, you can build your own pipeline. It doesn't matter if you have a small team of a few people or a big pipeline. It is basic that all the basic that I will introduce here are what every visual effects pipeline uses, with a few changes here and there. The second part that we want to do, and that's basically the core of each TD meetup, is we want to have a discussion. So I will do an introduction into visual effects pipelines, and then the second part, I want you to join me into a conversation, share your experience, ask questions, answer questions, whatever it is. What is a visual effects pipelines, which always includes animation and video games. A film and games pipeline regulates the process from the idea to the final product stage. It makes sure that the steps and departments are clearly connected and work towards the consumer product. That's kind of the dictionary definition. So what is basically the purpose of a visual effects pipeline, or pipeline in general, is to guide the project from start to finish. That's it. It's not something mystical or something like that. It also connects departments with each other. It's clearly and to some degree automated workflow. The workflow is the important part. And it's kind of a project of management. So pipelines basically do everything that is not kind of artistic. Everything surrounding the arts, everything around the creation, everything that interconnects everything, that is what pipelines do. They connect the different stages of the process, the different art departments, basically. And the funny thing is, a lot of people think that pipelines are automatically big chunks of code and Python code and software and so on. And actually that is a part of it, but it's actually not the most important part. And I have this permit, which basically shows you what is the core of a visual effects pipeline. And it's basically 4 steps. The first step is actually folder structure. It's a very simple folder structure. That's what you need. It doesn't matter if you have code or don't have code. You need to have a structure where you submit your files, your renderings, your Maya and assets and shots and so on. So a folder structure is the base of every pipeline because it defines your workflow. You know where to put your files. You know where to find your files. So this is very basic, and it's basically every project, a digital project, has to have a folder structure, and this includes also what we do here. The next part is the naming convention. How do we name things? Inside the software, outside the software, the files, the folders, everything has to have a clear naming convention, which to some degree connects with the folder structure because obviously we named the folders. but now we also name the files correctly. And a lot of times in projects, we want to get like secondary or meta information out of that, especially if we don't have something like shotgun or some meta saving description or something like that. The third level is the software pipeline. And that is where we start to interconnect between how are all departments connected. So if modeling is done in Blender, how does this connect to the texture in Mari or wherever it's Substance Painter or wherever it's done? How is that connected to the lighting and animation in Maya? How is that connected to the effects in Houdini and so on and so forth? So it's basically defining how each department works together, which includes which kind of file format they exchange and so on. And then last but not least, what most people think as what pipelines are is actually the script pipeline, which automates everything that we just talked about. We automate the processes, the interconnection between software and so on. But that is basically the last thing you should do. First thing that you should do is folder structure, then the naming convention, then software pipeline. And if these three are set and strong and maybe done manually in the beginning, then after a while you can top off with automation and scripts that help you to basically simplify the process. This is how a pipeline structure, project structure could look like. Basically very simple. We also count them, so we have this clear what's at the top, what's at the bottom a little bit from beginning till end. That's why we have the counts here. But basically it starts with a simple pipeline where we have all our scripts, sandbox, planning, pre-footage, assets, shots, renders, and post. So this is how I would break it down, basically what's inside. Pipeline includes all our scripts. Everything that is Python script plugin related, that is in this folder, obviously with subfolders, but that is here are all the scripts if they are project related. Obviously, if you have a studio and you have studio pipeline, maybe there is something else. But if it's for the project, it could be everything here. Sandbox is actually very important. If you work in an environment, you always have some temporary files, some secondary rendering, something that you maybe don't know where to put. It's good to have a sandbox in the project to avoid that people save it locally on their computer. Because it can happen that they need to share it with other people. Every one of you probably had this experience. You did something and you suddenly find yourself in a situation to share it with a colleague, or it's actually relevant for the production, and suddenly it's somewhere local on your computer. Maybe your computer goes up in flames. So having a sandbox where you just throw stuff that is saved in the network gives you the opportunity to share it easily and to not get lost that is there. And also for things that you don't know where to go, but they're related to the project. Next one is planning. And planning is basically more a producer environment. That's everything surrounding that. Obviously, as a project that is not distributed is a failed project. So there could be something like that. So more on the producer side. Doesn't have to be here, but that's how we structure that. Pre-production, obviously, everything that's related, you get references from the client, references from the director, and so on. Everything that is related here, that is basically in the pre-production. Then we have a footage section. And the footage section is basically everything that you use that is not directly for this project, but can be used for the project. Your HDRs, basic texture, basic shader, basic scene assets, also template assets. So everything that you reuse basically could be stored here. It's also a good pre-production stage where you just collect things that you think, oh, this could be nice. We have a bunch of flower textures and so on. So we can basically prepare here. Next one is the assets, because the first stage of every production is the asset creation. It's the modeling, it's the texturing, and so on. It's the shading. That's where we structure. Here are different ways how to structure this. You basically can approach it from two different directions. Either you go with starting with the asset and then going to the task. So each asset has each task. Or you flip it and you start with the task and each task has its asset. You can say asset name, and inside is geo, rig, shading, texturing maybe. Or you can go the other way around. You say geo, and then it has all the all the assets rigging and have all the rigs. It depends a little bit on how you structure it, but that's basically the two options. Most of the time you start with the asset, and each asset has every basically department in it. And also what we generally do is separate between work and publish. And the simple rule, what is work is when you work on it, and publish is when you want to connect it to someone else. That's the reference file that you use. So for example, a modeling publish file is the one that the rigging references in the rigging see. So if they update it, obviously that will be the one that's updating. But that is very important to separate this clearly, because then you know it's not like the last version, it's literally a separated version of an object that are referenced or imported or something like that. But the next one is the next stage after assets is the shots. And there's some simple thing, for example, in terms of naming. I highly recommend to name your shots in 10 steps. It's the simple reason is, and maybe you saw that in your own production, is that it can happen that we have in-between shots suddenly. Oh, we need an in-between because of something happened. If your shots are 1, 2, 3, 4, 5, there is no in-between. So you start to call it 2A or something like that. Or you have to call it 95 or something. So to avoid that, we call everything 10, 20, 30, and so on. And then if we have an in-between, we call it 1.5. So we still have we can go in one direction or the other direction if we need even more, or you can 1.1. It depends on how you structure it. But by having the 10 steps, we basically can go here. And again, inside that will be animation, FX, lighting, compositing, and again, we go back to work and publish. Then obviously, after we finish that part, we have a rendering stage. And here are all the renderings, everything that we put out as an image. That's where we go. We order that basically per shot. And this can also include other things, like specific areas of renderings. If we have play blasts and effects or whatever, in betweens, we can put them here, but we definitely have the final rendering also in there, basically. And then last but not least, we have everything that is related to the post-production for the editing and grading and delivery. So everyone knows how to figure things out and how to access that. And that's basically the structure. This is probably more related to an independent project that is not in a big studio or something like that. In a big studio, you probably can maybe separate a few things and put them in your studio pipeline and put just basically half of this in your product pipeline. But that's one of the ways that we can approach that. The second layer now basically is the naming convention. And that is where we have to decide how to name things. And it starts with how to name files, but it also continues how to name assets inside software. How is the node called in Nuke, in Maya? How is the asset called in Maya? So there's a lot of things that we can do to decide it. And it's very important that we define that, because it should not be something that people make up. That's the worst thing you can do, because what we do also with all of that is to create consistency and structure. And with that consistency and structure, what we can do later in the final stages of our pipeline is to create scripts that use these consistencies to find things. And one of the most common consistency thing that you see in visual effects, animation, and games is the underscore. So by putting an underscore instead of a space with signal, there is a separation between what I have before and what I have next. So there's two different things. And obviously, everyone of us who already did Python, we know we can split for underscore. And then we have basically a list of separate items. And each of the items should be something else. So in this case, for example, if we look at this example, Mike underscore Rick underscore V001 underscore test.ma, we basically break it down. If we, for example, break it into underscore, we will break it down into name, task, version, comment, and extension. And we can basically use that by breaking it down and inform ourselves. Okay, so what is the current task? Oh, it's Rick, by taking the second item. What's the current asset? It's Mike, and version, and so on. It's important to define this, to define the hierarchy and define the order and so on, because later not only we take away the guessing game, and people call it this way, some people call it V1, some people call it V01, some people call it V001. So we have to define it as clearly as possible in the beginning, so there is no guessing game. Obviously, in the last stage, we can automate how things are created. But at the end of the day, the first stage is always to define that manually, and then we can always basically define that with scripts later stages of the process. And this is basically how a naming convention structure can look like. I break it down quickly for you so you're not completely lost here, but it's basically what I just talked about. So we basically have the two areas of work and publish, basically the one that is still in process and the one that is imported or referenced into the next department. And obviously the work one has more information than the publish one. The publish only needs the name of the shot or the asset, the name of the task, and that's basically it. It should be as small as possible. And it also doesn't really need a version. You can save version as a meta, that's possible, but generally it should be a file that is just replaced and the reference finds it every time. So there is no version 01, version 02. It's always the same version. It's the newest version, basically. It's the only version. Compared to that with work, we have a lot of things that we can do, including things like the rendering files. We need also to define that. How does a rendering file is? Where do we put the AOVs, for example, and so on. So there's a few things we need to define. It's not super magically, but it's important to do that as clear as possible. Even though we have it maybe later in scripts, it's important that everyone understands how things work in the whole thing. And this includes also specific ways of how things are shortened. So for example, photo scan is called maybe scan, or modeling called geo, and so on. So this is very important to define so everyone knows exactly how to do it manually, or what things mean if they read geo or scan. What does that mean? Besides that, we have a few other rules that basically make sure that we don't do something weird. So for example, we do everything's in English. We don't use spaces. We use underscores. We call versions with V and then 3 digits. And names are, in this case, were set in our initials. So I'd never call Alexander Richter. If I need to add my artist or author into that one, I will call it IR, basically. And then a few other things that we can do. But basically, what the naming convention is to make sure that it's very clear how to name a file, how to name a folder, and how to name assets inside software. If you have a key light, what's the name? If you have a group, what's the name? For example, if we have a group, we will call it whatever it is, _GRP. So if you have a script that looks for groups, that's one way to find it. Besides obviously looking for the type group, we can also use the _GRP, and then we find all the groups that are interesting for us. Some of them can be replaced through things like types inside the software. Some of them can be replaced through something like Shotgun, for example. We don't need to put the artist name into the file name if we have Shotgun or any database tracking everything. So it's like extra information. Obviously, the Shotgun or whatever will know which artist created this version. So we don't have to brand it to the file, but it's possible, especially if you do it manually or less complex. That's a way to do it. Same thing for comments. You can't put comments into the file name, broken, needs updates, whatever comments you want to say. This can also be obviously put into the database, into the management tool, basically, that we use. The third layer is basically that we have to do before we even start to think about scripts or anything in pipelines is to define the software pipeline. The software pipeline is very important, and it basically is saying what is every department using as a software. This includes plugins, this includes versions, and how are they communicating with the other departments and sometimes different software. So for example, in this case, modeling uses Maya and ZBrush. So the data type that they use, and that's also very important, is Maya binary. as you probably know, in Maya, we have two options, Maya ASCII and Maya binary. So we say, no, we only use Maya binary. Okay. So, and then for the zebras is ZTL. That's what we will use. So how does this information go to basically rigging? So it has to be imported and it has to be moved through binary. So there cannot be any ZBrush files at the end of the day. It has to be a Maya binary file. That's important. So when we publish, it has to be a Maya binary. And when we import in rigging, we import the Maya binary and so on. So, and then, for example, here you can see if we use in animation, we reference the Maya binary. And then if we go to shading and lighting, we reference the ABC file and so on. So you can see basically how we connect each department, which software they use, which renderer they use, and how information are flowing. So that is the kind of a software flow chart, if you want to call it that way. And this includes also to clearly define which version, in this case, for example, it's a little bit older here, but like Maya 2023, which RenderMan version, and all the plugins that are essential. That should be very, very clearly defined. So everyone uses the correct Maya version, Houdini version, Nuke version, and so on. And no one is like, one is working on Nuke 12 and the other one is working on Nuke 14 to avoid also any clashes. Obviously, we can automate that with a startup script, but that's the first level. And with that level, obviously, we can communicate to a pipeline TD. This is the structure. Can you write me a few scripts to make sure that this structure is followed? And then last but not least, and that is basically the top level of every pipeline, that is the script pipeline. That's when we start to write Python code or even MEL or MaxScript or TCL code that helps us to enforce what we just talked about. They enforce naming conventions, they enforce the connection, exports, and so on. And so we can basically write scripts that interconnect. And obviously Python is the best way to do so because Python can be used in any visual effects animation games DCC. And then we can basically, if we combine that with PySide, as anyone who did the advanced masterclass with me knows, we can basically create UIs for any software. As you can see here in this example, created a loader for Maya, Max, Nuke, and Houdini, and we can do it for any other software the same way. So basically how a pipeline can look like, this is an example. You can find it on GitHub. It's called Plex. It's my open source pipeline. This is how, for example, inside the pipeline folder, as I mentioned in the beginning, how it can look like. You have a bunch of subfolders with a bunch of scripts that initialize basically the pipeline, and it will allow the artist to have a startup that they double click, or in bigger production in Linux, you have a terminal where you start the project via a few lines of commands, and then basically it will start your software and the software gets into a specific project stage. And with other applications, we help that to do it. If you're interested how this can look like in definitely more advanced fashion, this is something I can recommend to check it out. Plex, you can find on GitHub. It takes a moment to get into that. There's also a wiki in here where you can check it out and read a little bit behind the scenes. Also, parts of this presentation is exactly from the idea of Plex and how I built it. So this is also something that could be interesting for you if you are interested how the script pipeline actually can look like. What are the tools that you need in a script pipeline? It's pretty simple, honestly. If you think what a pipeline actually does is this free tool sets that we do. Every pipeline basically only does more or less this free tool sets. So the first one is to set up the software. So if you start Maya, Max, Houdini, Nuke, whatever, that the resolution is correct, that the frame rate is correct, that the plugins are checked in, that the paths are included, including the pipeline is included. So you can simply import scripts. So we set up the software so it's ready to start working, including shotgun and whatnot. That's the first stage. We make sure that when the artist starts, he opens the right software. They have the right plugins already connected. They have everything already prepared as much as possible, and they can start without thinking and setting things up. And that is what a pipeline is. A pipeline is setting things up. The other two elements are as simple as that, basically. Also, it's about save and load and export and import. And that's it. Basically, save and load controls basically the creation of files, and export and import controls the submission of files to other departments and basically accepting them. So when we start working, we save a file. When we need to open something else or reopen it later, we load a file. And when we need to give it to the next department, we export it and they import it. And that's it. At the end of the day, all of that it's called publishing, it's called whatever. But at the end of the day, it's basically save, load, export, and import. And everything in the middle of that. But if you break it down, what a script pipeline actually does is set up software, save and load, export and import. Everything else is department content. So any auto rigger is not pipeline. An auto rigger is a rigging tool. A rigging TD writes an auto rigger. A pipeline TD writes a tool to import the model into the rigger. A pipeline TD writes a tool to export the model or the rig to the animator. That's the thing. So that's the difference. So if you think of script pipelines, obviously they include auto riggers because you can put them into the pipeline. But what a script pipeline mainly does is to connect departments and make all the kind of bureaucracy and organization and management of the whole project and file simple, easy, and best case a one-click solution. So the person who's working can focus on the art, on the job, instead of focusing how this interacts with other departments, with the project, with the conventions of the environment. For example, how it can look like, a pipeline is basically something like this. You can have this kind of a sub-software here, or you have a batch file that you double click or whatever. And here you can basically open software, open load scripts, and then open the shot, the asset, and so on. There's multiple ways how to do that. If you work in a bigger professional production, it's mostly about Linux terminals. If you work more on Windows, it's mostly more visual at the end of the day. And then what we as if we start to become pipeline TDs, or if you work in a project where there's pipeline TDs, these are software that can be written. For example, the most typical software that we get applications are Loader and Saver, to make sure that if you save something, it follows the naming convention. So it's not you manually typing, how was it, V1 or V001, I don't remember. It's automatically, it enforces, like pipeline scripts enforce and simplify all the things that we talked about. They enforce and simplify the folder structure by automatically creating folder. They enforce and simplify the naming convention by automatically naming and opening files correctly, and so on. So using scripts basically enforces and simplifies the three levels that we talked about of folder structure, naming convention, and so on. So that is the idea here, and that's why we built them. And obviously they save enormous amount of issues and time. As a final part is, obviously, now that we know how to build a visual effects, animation and games pipeline in all the simple parts, obviously we didn't dive into the scripts itself, but we dived into the main elements. We also have to understand, so what's exactly is the job and the requirements for a pipeline technical director? If you want to become one, or you understand how do they work with other people and other departments. A pipeline technical director is the bridge between the workflow of each department and the production as a whole. So the idea is that, as I mentioned, a pipeline technical director is the one that connects everything with each other. And a department technical director is who helps the artist in the department specifically. An animation TD writes animation tools, and rigging TD writes rigging tools. Modeling TD writes modeling tools. A pipeline TD usually writes tools to start a department and to finish a department. That's the most common definition. The in and output, that's the pipeline TD. And everything in the middle, that's the department TD, basically. So what are typical requirements for pipeline technical director. It's basically advanced Python. You can have Mel, you can have C++, but advanced Python is an absolute must because pipeline technical director are actually programmers. There is no way around it. Where a rigging TD doesn't have to be a programmer. It's good that they know basic Python, but they're not considered most of the time programmers in that sense. Any other TD doesn't have to become a programmer, but a pipeline TD is a programmer. They have to know things like Linux, Shell, and Git. They should know a variety of software. It's often not enough to know only one. And that is also the difference to a lot of department TDs. A rigging TD mostly knows Maya, maybe something else, but generally Maya, or if you are 3ds Max, but they are mostly know one software. Lighting TD, maybe more, but it depends. Modern TD, maybe more, but it depends. But it's mostly like one focus. Pipeline TD doesn't have to know all of them, but he has to feel comfortable working in them and specifically writing scripts for the input and output. You don't have to be an expert in Houdini to write a save or load or import or export script, but you need to know how to work with the API and so on. And that's why it's important to know the basics. And obviously also related to any database kind of handling thing like ShotGrid nowadays, FTrack, databases, and so on. And obviously they have to understand the production pipeline and every step in there. So it's not just something you can do on the first step. I generally believe there is no junior pipeline TD because a junior pipeline TD means like you're just beginning a little bit. I think that you can only become like a pipeline TD if you are you have years of experience, you have obviously background in kind of scripting and programming, and you jumped a little bit between departments. So you're familiar, at least in one department, you're an expert and you are familiar with a lot of the bridges in between. So you are able to connect with them. And obviously good documentation and communication skills are super important because you have to build bridges at the end of the day. And if you want to put pipeline TDs basically on the scale of where they are, so if we look about, here the lowest would be being an artist, the highest will be a technical, and then the lowest will be artistic work, and this will be more technical work like coding. So that if you are here at the top, you will be like pure programmer. You don't do art at all. You just basically Windows programming, Linux core programming or something. And if you are here at the bottom, you basically are artist. You don't even touch software in that sense. You just do art basically. And if you see, there's like the 4 steps that I generally say that we have in the industry. It's artist, technical director, and last are software developer and R&D. That's kind of, so pipeline TD is a little bit in that, depending on what you do exactly, what kind of background you have and what's your job, it can be a little bit different, but generally there are more on the software development side. But still, compared to most software developer, they're still closer to the artists that talk to the people because they have to connect departments, while a lot of software and R&D creating tools, sometimes a little bit independent. The pipeline TD often has to communicate with each department, what they need, how they connect, how they export, how they import, and so on and so forth. And that's basically it. That's what I wanted to communicate for today. And what we basically learned is that if we think about it, that we have 4 steps to create a pipeline, and the 4 steps, especially 3 of them, are not related to scripting at all. So the first step is folder structure. We need to make sure that everyone knows where to save, how to save everywhere. Then the next step is naming convention. We need to know how to name the files, how to name the folders, and how to name the assets inside our basically environments. We have to understand the software pipeline, how to interconnect, what software version everyone's using, what file extension they save in, and so on. And then on the last step, and that is basically an optional step, because with the first 3 steps, we basically can make a project. We don't need scripts. We can literally, if we define the first 3 steps, we can start a project and everyone just manually names the files, manually does this, manually explains how to export something or does them. And then everyone just follows those rules basically, and that's fine. To make it easier, and especially with more people to avoid mistakes, we can create all the saves and exports and software setups. And for that, we usually use Pipeline Technical Director to accomplish that. And that is basically the level that we do to create a visual effects, animation, and games pipeline. Yeah, just join into the discussion if you have questions, if you want to share your experience. Maybe you are a pipeline technical director, maybe you work with them, or you work in pipelines in general, whatever the interest or the topic that you want to address. And then so we can have share what we know and discuss things about visual effects pipelines, animation pipelines, and games pipelines, basically.
I welcome you to join us live and also watch the previous episodes, and I'll see you on our next TD Meetup.